Okay, this video is going to go over the 6.3 notes. So we're going to prove triangles are similar by AA. So that big picture on that means that if you know two of the angles are the same, that's sufficient to say that the triangles will be, or the shapes will be, the triangles will be similar, because if two angles are the same, then that means that three angles have to be the same. So that's our underlying premise. So once again, similar polygons have the same shape, but different sizes. So remember, the angles are all the same. The angles are congruent, and the sides are in proportion, and that proportion is called a scale factor. Okay, so that's kind of a little review about 6.1, because we're going to use the same idea now. Okay, the angle-angle similarity postulate, that tells us that if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. Okay, so they're not congruent, they're similar. So look at these two triangles below. Do you see how I can make that similarity statement, which is right here, because I have been told that angle J equals angle X, and that angle K equals angle Y. So those are two angles that are equal in each triangle. Therefore, I can state that these two triangles are indeed similar. If I knew the side lengths, I could check that they're in proportion, but I don't even need to do that, because once I've established that two of the three angles are equal, I know I have similar shapes, and therefore I know the side lengths will be in proportion, and I could get a scale factor. So let's go on to the next page. Okay, example 1, it says use the AA similarity postulate to determine whether the triangles are similar, and if they are, write a similarity statement and explain your reasoning. Okay, so I see I have an angle of 26, which is C, and an angle of 64, which is H. So I am missing an angle in both of these triangles, and it ends up that in the second triangle, the missing angle is 26 degrees, and in the first triangle, the missing angle was 64 degrees. So I now know that those are similar because I have all three angles actually equal. So once I establish the fact that I know the angles are all equal, by AA, I have a similarity postulate. So let's write our similarity statement. So it looks to me like angle C is going to be congruent to angle K, and angle D is the right angle, that goes with G, and angle E, that's the 64, goes with H. So these are the triangles in the proper order to indicate the similarity postulate. Okay, example 2, they're asking us to show that triangles are similar. So show that the two triangles are similar and write a similarity statement. Okay, so the two triangles are located in this triangle. Okay, so what do I have? I know that this big angle A, or the top angle A, is going to be in common to the small triangle and the big triangle. I also know that angle B is equal to angle C. So I have two angles in common. So by AA, I can state the following. Triangle EAB is similar to triangle, this is the big guy, DAC. Okay, so I have that statement now based on the visual of what I'm seeing in the triangle. Let's go to the next triangle pair, And what do I know here? Okay, here comes the parallel lines again. If you consider that RT is a transversal cutting line SR and line TU, okay, so this is your transversal right here, then don't I know that the alternate interior angles are equal? And don't I also know that vertical angles are equal? So since I have vertical angles and alternate interior angles, I can make a statement about the similarity of these two triangles. And let me just get rid of that so I can see the letter. Okay, so what's my similarity statement? Why don't we start with V? V, R, S is similar, start with V again, V, T, U. Okay, so I've looked at the triangles based on parallel lines. I got alternate interior angles equal, and then based on my vertical angles, I know that those angles are equal. That gives me two angles, and by AA, I can prove that these two triangles are indeed similar. So let's go on to the next example 3. Okay, example 3, it says a flagpole casts a shadow that's 54 feet long, and at the same time a woman standing nearby who is 5 feet tall casts a shadow that is 6 feet long. How tall is the flagpole? So a couple of things you need to know about this. These are sunshine problems because they are casting shadows. Okay, so what you know is that the angle of the sun, which is this top angle right here, will be equal in both scenarios. So now you have the sun angle equal and you have the right angle equal, and that's why you can say by angle you have similar triangles. Okay, so since you have similar triangles, you know that the corresponding parts will be in proportion. So you can establish that x, vertical height, over 5, vertical height of woman, equals, go back to the bigger triangle, 54 shadow length over 6 shadow length. Do your cross products, I'll do that down here, and you're going to get 6x equals 54 times 5. So do that in your calculator and divide by 6, and you should get that your x, so your height of the flagpole, will equal 45 feet. So just check that math, make sure you're getting that. Okay, that takes us to the extra practice section. So it says determine whether the triangles are similar, and if they are, write a similarity statement. So again, we're missing an angle. Solve for the missing angle first, and then we can talk about similarities. So when I do my math, 180 minus 90 minus 53, I get 37 degrees here, and therefore I'm going to get 53 degrees here. So these triangles are similar. Now write your similarity statement. So I'm going to say start with the 90-degree angle, y, and then go to the 53, x, and then go to the 37, which is z, and follow the same order. 90, and I did 53 next. 53 is A, and C matches the 37. So these two triangles are similar, and that's my similarity statement. Okay, the next example says show that the two triangles are similar and write a similarity statement. Okay, once again, I'm going to use the transversal. That's going to give me these two angles indicated in purple as alternate interior, these two as vertical. So they are indeed similar because I have two angles. So by angle, I can say these triangles are similar. And starting at the vertex, I go F, and then to the alternate interior angle, E. Follow the same pattern. Start at the vertex, alternate interior angle, H, J. Okay, look, the same kind of triangle we had in the other page. So that top angle is equal to both the big triangle and the little triangle. So they are indeed by AA similar. So start with the big vertex angle. So that's Q. Go to the 44, R, and then P. That's similar to start with the vertex, go all the way down to the 44, and S. And there's your similarity statement. Okay, we have one more extra practice. We'll do that on the next page. All right, this last problem is a school building casts a shadow that's 26 feet long at the same time a student standing nearby who is 6 feet tall casts a shadow that's 4 feet long. How tall is the building? So again, this is a sunshine problem. The angle of the sun is the top angle. That's the same in both. The building's at a right angle, the person's at a right angle. So that gives me the sun angle and the right angle as two angles. So you can say that these triangles are similar because of A. Set up your proportions. X is to 6, so those are the heights. Just like, go back to the big triangle, 26 is to 4. Do your cross products. So if you say 4x equals 6 times 26, and divide both sides by 4. So 6 times 26 divided by 4, and you should get an x, or a height of the building, equal to 39, and everything is in feet, 39 feet. And that ends the 6-3 notes.